Hi everyone. So I want to just give you a few hints on question page 308, number 24, and then I'll go into an explanation on it. So if you're having trouble with it, it's likely that you're just unsure of exactly what they're asking. So a rectangle is 80 centimeters long and 20 centimeters wide. Find to the nearest degree the acute angle formed at the intersection of the diagonals. Lot of words. So the first thing I'm going to do is I'm going to draw a rectangle that's 80 by 20. Okay. I'm going to do my best here. So I have this rectangle. I forgot to plug my pen in. Let me do that. It's 80 by 20, and it wants to know about the acute angle where the diagonals intersect. Let me change the color of the diagonals so you can see it. There's one diagonal, corner to corner. Other diagonal, corner to corner. Okay, so now I know that it's 80. Pen's not working. 80 by 20. Find to the nearest degree. So find is telling me what to do, what the question is asking me to do. That's the do. The acute angle. Okay, so acute angle less than 90. Formed at the intersection of the diagonals. So this is the intersection of the diagonals. So the angles that are formed, there's two angles here that appear to be obtuse, and there's two angles here that appear to be acute. So you're looking for this angle or this angle because they're vertical, so they're equal. Okay, now we have to remember the diagonals in a rectangle are congruent. And they bisect each other. They're congruent and they bisect each other, which means all of these are equal. Okay, so now I drew it the long way. If I drew it the other way, it would have been a little bit easier to see, but you can see you have a triangle here that's isosceles with a base of 20. So I'm actually going to redraw it straight up. It has a base of 20, and this is the angle I'm looking for. All right, well, if we're going to be using trig here, this is where I kind of have to think. These isosceles triangles are going to be with us a lot. The only way you can get a right triangle is if you drop an altitude. If I do that, I drop an altitude, that's perpendicular. Ask yourself, what is it doing to the 20, to the base? Hopefully you said these would be congruent, making this 10 and 10. Okay, and so if you look at this and we would have to be able to find this angle right here, but unfortunately, I don't have enough information. Remember, if we're going to use trig in that triangle, I need two parts. Right now, all I have is a 10, and I need another piece of information to find x. The 90 will never be the piece of information I need. So thinking long and hard about this, I actually probably need maybe one of the sides, okay? And so if you think about this, that altitude we drew was this side, was that right there. So if I went all the way across and the whole thing is 80, then each one would be 40. So this would have to be 40. Now I have enough in order to find x. I need x, okay? All right, so that's my reference angle. My opposite and my adjacent are what I have, which is tangent. So using the structure of the equation, tan of x equals 10 over 40, so 1/4. I need the angle. I should use the inverse. So inverse tan, using my symbols, of 1/4. All right, and I grab my calculator. Inverse tan, 1/4, 14 degrees. So if this is 14 degrees, well, then this would be 14 degrees. And so the whole thing would be 28 degrees. So to the nearest degree, the acute angle formed at the intersection of the diagonals would be 28 degrees. All right, hopefully that was helpful. Have a great day.